The broadcast is now starting. All attendees are in listen-only mode.
Hi, thanks everybody for joining today. My name is Andrew Shikyar. I lead marketing here at FIDO Alliance. We're really excited for today's webinar, which will serve as both an overview of the FIDO Alliance organization, our technology, and our approach to related payments initiatives. And then we'll do an integration case study from Visa. This will provide you with an overview of 3D Secure, the 3D Secure initiative from EMVCO. We'll also show you how FIDO UAF has been integrated into the Visa ID intelligence solution to help provide a better 3DS user experience and a strong solution for merchants and issuers worldwide. Covering this content today, we have two expert speakers. First, we have Brett McDowell, the Executive Director of FIDO Alliance, and then we have guest speaker Tanha Nguyen, Client Implementation Leader from Visa ID Intelligence at Visa. Before we get started, just a couple housekeeping items. First of all, yes, this will be recorded, and the slides and replay will be shared with you afterwards. Secondly, feel free to ask questions in the GoToWebinar client. So the software client has a question dialog box. You can type in a question there. We'll answer them midstream if possible, and otherwise we'll try to take as many as we can in the Q&A at the end of the session. So at the end of the session, we'll have a Q&A time where we'll select certain questions and ask them to our panelists and our speakers. Last but not least, please take a moment to fill out the survey at the conclusion of the webinar. This gives us important feedback that helps shape our webinar program moving forward. So we greatly appreciate you taking just a couple seconds to fill that out. So with that, let's get started. I'm now pleased to introduce Brett McDowell, FIDO's Executive Director. Brett.
Thank you, Andrew. And thank you everyone for coming. We definitely have a full house registered for today's webinar, and hopefully you will get some more people taking advantage of this recording. So if you are here and you learned something useful today, by all means share the recording with your colleagues afterwards. So I'm going to talk primarily about FIDO authentication. I'm going to start with the organizations that are behind this technology. What you're seeing on the screen right now are the companies that sit on the board of directors of the FIDO Alliance. And what you see is that we have balance between the consumer electronics leadership in the market worldwide, from the companies that provide the operating systems and the web browsers, Google and Microsoft. We have leading OEMs in both the PC and the mobile market, as well as the chip manufacturers. And that's important, and that's something I want you to keep in mind as we get into the security value proposition of using FIDO authentication for your mobile use cases, because you really want those secrets tied to the hardware. One of the critical authentication factors is what you have authentication factor or possession. We also have leadership from enterprise security companies, biometrics companies, and perhaps most importantly is that all of the technology that's been developed by the FIDO Alliance is being built to solve real-world problems. You see that by the representation on the right here. These are companies that they're not selling a technology necessarily. They really need a better authentication solution. They're the relying parties for this technology. We need better authentication, better user experience, better security, and here are our use cases. And we at the FIDO Alliance very much listen to our relying parties to ensure that what we develop is solving real problems. So what is the problem? That includes shared secrets overall. So we're talking about authentication today. We're talking about credentials. How do I authenticate to an online service? Well, I present my credential. And traditionally, life before FIDO, primarily the credentials that you're presenting are shared secrets. It's something the user knows. It's something they have to provide to the application. They're entering the secret on their device, probably web browser, for example, or mobile app, and then that browser or application has to take that secret, pass it over the internet, and give it to the application in the cloud that compares the secret to what it was expecting. So this, it doesn't just affect passwords, which has been the focus of the FIDO Alliance. It is also relevant to one-time passcodes. Now, you normally think of one-time passcodes as a proof of possession, but in fact, they're a shared secret. The presumption is, well, you only know the secret if you have the correct device. But in truth, through compromises that are well reported now, you can't count on that. You know, this one-time passcode very well could have been phished from the user or compromised at the SS7 layer. And even, of course, I imagine today, given my co-presenter, we probably have a lot of people familiar with the payment cards industry, and so the PAN is yet another shared secret that payment card industry has been improving using things like tokenization to move away from some of those vulnerabilities. So shared secrets are vulnerable because they exploit the weakest link in a traditional end-to-end authentication flow, which is the user. If you can trick the user, you can get the secret, and then you can attack the account. So not only do we have a fundamental vulnerability in the authentication models, you know, pre-FIDO, but these vulnerabilities are exploited, and they're real costs to the industry. So here are just some statistics that we could be citing many of them, you know, over 5 billion in losses, you know, from those shared secret in card not present fraud. We have over 80% of all data breaches have been studied and reported as caused by the compromise of a password. As simple as that. Shared secret compromise, over 80% of data breaches. And those data breaches are often the first step in achieving that breach is phishing a user for a credential and then getting into the network and getting an escalation of privilege. And we've seen a 65% increase in phishing attacks. Phishing has been around for an awfully long time. So why are we seeing a 65% increase now? Because this continues to be the most profitable way to attack a system. And the data breaches are increasing year over year. So not only is this an expensive problem today, it's getting more expensive every year, and exponentially so. It's actually getting worse than a linear curve. So now let's take a step back. Why is this authentication scheme so broken? Well, this is a very simple diagram. This is as simple as we could put it. You have the end user who is communicating with over an online connection to some shared secret database, and the end user has to provide the secret, and it has to go over the internet and get checked against what's been stored on the server. So what does that mean? That means that the secrets are stored on the server. So you have this giant database of these secrets. That's quite a honeypot. It's kind of attractive to go after this repository of credentials. And you have this end user that all I really need to do is trick the end user. I don't even need to compromise the integrity of their device. So at FIDO Alliance, we set out on a mission to fix this problem and deliver better authentication, simpler and stronger authentication. Now, a lot of us that were involved in the creation of the FIDO Alliance were already living with two-factor authentication. Myself, I was product manager within my product portfolio at a financial services company was the two-factor authentication solution. So I was very well aware of the low opt-in rates for two-factor authentication. Even when we tried to do direct marketing, get more of our users to turn on that second factor, they just wouldn't do it. And if they tried it, they backed off because it's a bad user experience. So what we knew is that we had to design for a better user experience first, and then, you know, add better security. We knew that we were wasting our time if all we did is come up with an extra step that you could take as a user to make yourself more secure. We saw the failure of that value proposition already in the marketplace. And we also knew that we wanted scale. If we were really going to tackle the password problem, we had to have open standards. This problem is just too big for any one company or any one country even to tackle on their own. So it had to get net effect economics of open standards. And we decided to use public key cryptography as really a proven technology. It's been around, throughout PKI and the smart card world, but PKI was never really embraced in the consumer space. It wasn't designed to be, kind of user-friendly and easily deployed. So what we did is simply take the necessary security component, asymmetric public key cryptography, so that you got a private key and public key, and we don't have a role for certificate authority. We don't have that infrastructure, if you will. So PK without the I. Or PKI for the modern age, however you want to think about it. And we wanted to get the user experience down to nothing more than a single gesture from the user. What is the theoretical limit of how easy we can make authentication? Well, how about if I just touch something, look at something, maybe speak a word? What could be easier than that? And so that was the focus on the user experience. And we wanted to make sure that in the end, the result would be phishing-resistant multi-factor authentication. We wanted true multi-factor. We knew there'd be regulatory requirements. Many of us were subject to regulatory requirements when we put the alliance together. We wanted something that would pass the regulatory scrutiny for true multi-factor authentication. And hopefully by the end of today's presentation, you'll see that we've achieved those things. So what did we do? Again, the simplest possible diagram that we can show is we added the FIDO Authenticator in the middle of that flow between the user and the online application. So now the Authenticator has two jobs to do. The first job is it does a local user verification. So that means I need to challenge the user in some way, ideally with a single gesture for a better user experience, so that I know that I have the right user and I can pass that information on to the online application. But you could use a PIN or a password if you wanted to. The key is this is local on device. So if you're tricked to giving away your PIN, it doesn't do anyone any good because you can't attack a FIDO credential unless you have physical possession of that user's device. Because the authenticator's on device, the secrets are on device. So job one, user verification. Job two, cryptographically sign a challenge from the online application so that's not replayable, that's TLS encrypted end to end, and verifies that only the device that was registered could possibly deliver this result. So the very highest authentication assurance level, according to the National Institutes of Standards and Technology, requires that one of those multi-factors be a proof of possession of a cryptographic private key. So we have that here. So again, the authenticator can do two jobs: verify the user, typically through biometrics to get that user experience, and then cryptographically prove that this is the right device. The strongest possible proof of possession that is the device that you're expecting it to be. And then on the server, no secrets. The only thing the server has is the public key. So now let's talk about some of the companies that are already taking advantage of this technology. This is not a solution looking for a problem. This is not something that is in the kind of sort of the lab. This is out in the real world and already deployed at scale across hundreds of millions of users. So Bank of America, Facebook, Google, most recently, Microsoft's kind of a new deployer of these services, eBay, PayPal, Aetna. So you've got deployments here that are adding FIDO to a mobile app, and you have deployments here where you're adding a FIDO authenticator as a second factor over the web. So you've got both of those kinds of deployments that are out in the wild. And what you'll notice here, again, because of my co-presenter today, I'm kind of taking a financial services angle on this. We see that there are a lot of banks all around the world and payments solutions from all around the world taking advantage of this technology. That is not a surprise. Where do you need better authentication the most? Where is the value proposition the highest? Where are the stakes the highest? It's in financial services and payment. You have to compete on a great user experience for payment. And you have to defend against fraud because there's real money there and you are under attack. So here is another diagram, a little more detail about how FIDO works, and I'm going to focus here on the biometrics use case that I touched on briefly before. So here you have your authenticator in the middle. This is in the possession of the user, and as the industry trend, without any influence by FIDO Alliance, you can think of FIDO as kind of riding the wave of what was already a mega trend in the industry, which is to have modern consumer devices, whether they're mobile or PC or tablet, with built-in biometric capabilities where the biometric itself is saved on the device and never shared. So leveraging that, so you get out of needing to train the user to do anything because you're simply letting them do what they already do to unlock their device. So you already put your fingerprint down or you look at the camera. So wouldn't it be great if you could just log into all of your applications that way? So we do that, and then we add the security underneath. The private key that's stored locally and the public key that is stored with the server. So now your server is less of a honeypot. You don't have credentials that can be compromised and then replayed anywhere else. All you have are these public keys. There's a unique public-private key pair for every account, so privacy is preserved. There's no global identifier in anything that FIDO does. It's privacy by design through and through. And what I now get to go into is, again, very much designed by the companies that are the relying parties, relying upon this authentication capability. And so one of the first things that they said they needed is an ability to trust the device. How do I know this device is doing a good job of protecting that private key? How do I know this device is doing a good job of verifying that it's the same user? So we have this attestation object that's signed by the device and shared through something called the metadata service. And this is part of the FIDO standards standards stack of specifications that we have. And it is a public registry, a public infrastructure that we operate on behalf of the industry. It's a very simple online registry of all certified authenticators that take advantage of this. And so what that means is that you don't involve the metadata service in any kind of real-time authentication event. Let me be very clear about that. We're not in the critical path of any kind of authentication flow that you would have. Instead, you have a local cache. Your FIDO server has a copy of the metadata registry so that you can know all about the devices that have been certified without needing to ping our server. So it's like subscribe to it, maybe update your registry once a day, that sort of thing. And what you get to learn from all of this is the certification status of an authenticator, how it is going about verifying the user. Is it face recognition? Is it fingerprint? Is it a PIN? Is it a 6-digit PIN or a 4-digit PIN? This is all information you can get from the metadata and the manufacturer of the device and the model and any other attributes that manufacturer thinks are important for you to know. And again, not a global unique identifier. This is one metadata entry per model of authenticator. And then what's important is what you can do with that data. So you can make policy decisions based on the metadata of the authenticator, such as allowing you it ensures that there's conformance and interoperability. I'm specifically talking about the certification attributes within the metadata. FIDO Alliance, we govern those attributes ourselves. So if you see that it is certified, then you know that FIDO Alliance is saying that it's certified. We did the testing, and what that means is that this will truly interoperate. You don't have to worry about it, just breaking down. And also, it gives you the security level of the authenticator, and I'm going to show you more information about that in just a moment. And you can make policy based on security level, and you'll see why just in the next slide. And you also, through our biometric certification program, you can make policy decision based on this has been third-party verified to reach a certain standard of performance as a biometric. And that's true for multiple modalities. Face, voice, iris, and fingerprint are all being tested by our new biometrics program. So here is an illustration of the security levels for the authenticators. So this is what you might want to pin some policy to and process your scoring. I would say a recommendation is at least inform your risk-based authentication, it's kind of your trust scoring, or however you think about scoring sessions based on the capabilities of the device from its certification level. The other thing you might want to decide is whether it's been validated by a third party through the FIDO certification program as reaching the regulatory requirements. So when I talk about PSD2 strong customer authentication requirements in a minute, keep in mind that you can clearly pick an authentication level, and everything that's at that level or above passes PSD2 SCA requirements, because they do require a restricted operating environment if you are trying to get both authentication factors out of this single gesture user experience, which of course is the best option for you, as opposed to two different screen, the two screen user experience that it's harder to get users through. So that is an overview of all the components of FIDO authentication and the certification program that allows you to trust the attributes that you learn about from the device through the metadata service. And now I'm going to go in a little bit of a deep dive here, because answering some questions that were flagged for me ahead of the webinar. So we know we've got some questions about, well, what do I gain by adding FIDO to the biometric API that OEMs already provide to me on their platforms? And then we'll also get into the regulatory component after that. So I want to thank Knock Knock Labs published a paper enabling biometrics for mobile application authentication. I borrowed some of this analysis from them, and the rest is kind of sort of vetted by the security requirements working group at FIDO Alliance. So first, let's just acknowledge the obvious. You're going to offer the same user experience. So there is no advantage to the user experience per se. It's going to be the same, fingerprint on an iPhone or Face ID, whether you're using FIDO or not. So let's just get that out of the way. And then here are some other challenges, though, on the security side, if you are going it your own way and not leveraging the FIDO standards. So first of all, you're still just storing essentially a shared secret, even if that's a session token, authentication token that you're storing. You're still retrieving that and processing it, and I think the security community is well familiar with the risks of bearer tokens. They're subject to many of the same kind of man-in-the-middle and replay attacks. The security end-to-end with FIDO has been reviewed by the industry, not only specifically third-party security labs that have been brought in, but the protocol designers are the brightest security minds of the biggest tech companies. So you don't get advantage of that. It's on you to figure out, all right, how am I going to handle this secret that I have stored on the device? How am I going to get it off the device? How am I going to protect it from other applications on the device or attackers trying to get in the middle? And device fingerprinting, of course, is a well-known component in any risk-based authentication system, where you are getting device attributes off of that device, and that helps feed your policy. But your mileage may vary, and it's still probabilistic, and it's still a bit of an arms race with the attackers who can also read those same attributes and try to spoof the profile of that device. So you're not getting that strong cryptographic proof of possession. The other thing is, in terms of financial risk, to the return on investment for having your development team build out this custom solution around what's otherwise a basic device API, there's a long tail of devices out there. So you're either going to be in a position of saying, well, we're only going to support the major devices, and the rest of my users, they don't get this good user experience, sorry. Or you have to build out for all these other APIs on the long tail of devices, particularly in the Android ecosystem. And that just gets expensive and also hard to justify the ROI for some of those less popular devices. Development risk, this is kind of build versus buy strategies. I don't need to lecture anyone about that. This is just this idea of proprietary code that we have built, and how many of your developers really are familiar with that code, in case you have turnover. Competitive risks, so you're going to have, this is essentially your homegrown solution to try to protect this end to end versus following an industry trend. And not only is that an industry trend to adopt FIDO authentication, but it also gives you flexibility because FIDO is an abstraction layer underneath the user experience. So you can very quickly embrace other user experiences without changing your infrastructure underneath. You make one investment in FIDO authentication and then you're interoperable with everything else that comes to market that supports the standard, which is turning out to be pretty much everything else. And the opportunity cost. If you're investing time building to these custom device APIs, then what are you not spending your time on that might be beneficial to your core business? And last but not least, there's no clear path for proving that what you're doing meets multi-factor authentication. And in fact, you're setting yourself up for failure there because most of the multi-factor authentication regulation that I've been looking at requires either separation of devices or use of a restricted operating environment. And you can't really prove that in the same way if you're not using the FIDO standards that's already gone through review and engagement with like European regulators and US regulators and also regulators in Asia. So very quickly, this is the same list. If you do add FIDO, which is this challenge response protocol and the private keys on the device, you don't have the shared secret vulnerabilities. So all of that social engineering and phishing is off the table. Security end-to-end has been reviewed by the industry. The metadata service is free to use, so you're not paying for these device attributes. The ROI is well understood. This is the economics of open standards, which always benefit the adopter. The development risks are shared or mitigated because this is now an industry-wide effort. So whether you're using a solution provider or even if you are building your own FIDO solution, if you base it on FIDO, you're part of a whole industry movement that's using that technology. Competitive, change your UI, very flexible, living on top of the FIDO APIs, and the opportunity cost is very much minimized because your development teams can focus on your core business and you can use partnerships for your FIDO enabling your infrastructure. And again, not least of all, clear path for multi-factor authentication, strong customer authentication compliance because of the work that the FIDO Alliance has already done as your advocate with our government relations. And two quick examples of that. In the US, the National Institute of Standards and Technology and the White House, going back to 2014, removed the requirement that one factor of a multi-factor authentication be separate from the device accessing the resource. And this is recognition that the technology, through the work of FIDO Alliance and others, is considered now mature enough to enable two secure distinct authentication factors on a single device. So this was only binding for government applications, but it set a precedent that was later followed by the European, so the EBA, the European Banking Authority, and their regulatory technical standard as documented here in Article 9 around the independence of the elements, the independence of the authentication factors. So here, strong customer authentication can be achieved with a single gesture user experience, because they talk about multi-purpose device, so think smartphone. Helped by the FIDO metadata service, because you can say, oh, well, I know the attributes of this device because here it is being cryptographically signed by the device manufacturer, telling me what the attributes are. And one of those attributes is it's certified to FIDO level, let's say 1+ or 2, which means it's using a separated secure execution environment, which is your requirement for having multiple factors on a single device. And the last thing I want to say is FIDO is well aligned with other payments initiatives. We have had a memorandum of understanding to collaborate with EMVCo for several years now. We recently expanded that collaboration to define in detail how 3DS messages can be used to pass this valuable FIDO authentication data, which is from the attestation and the metadata service, including the authentication signatures, in a manner that is scalable and interoperable across the EMV payments ecosystem. So we are working with them now. So in the short term, the standards that are already published from EMVCo include the sort of placeholder, if you will, that FIDO data can go here. We're going to be publishing an implementation guide that shows you exactly how to format and pass that JSON object. And we're going to be collaborating so that that detailed information is a part of the core standard in the next version. So I want to thank you for your time today. Hopefully some of this was helpful. I did spend some time on that one set of questions, but hopefully they were relevant for you. And now it's my pleasure to turn it over to our spokesperson from Visa, Tanha. Take it away. Tanha, you might be on mute.
Sorry about that. Thanks, Brett, for the introduction. As Brett mentioned, my name is Tanha Nguyen, and I'm on the Visa ID Intelligence here. In my part of the webinar, I'll cover a few topics, setting the stage before showcasing a sample FIDO authentication implementation for use in payments. So I'll first start by introducing the 3D Secure protocol for cardholder authentication, providing the background on why cardholder authentication is useful, showcase some sample biometric authentication use cases. Next, I'll go over a brief overview of the Visa ID Intelligence Biometric service and how we have implemented FIDO authentication. And finally, I'll walk through an example of how the biometric service can be used for out-of-band payment authentication. So let's start with 3D Secure. 3D Secure, also known as 3DS, is a messaging protocol enabling authentication of a cardholder for e-commerce transactions with their issuer. So this authentication actually occurs prior to the authorization of the payment. The authentication event can be triggered when a cardholder is performing an e-commerce transaction at a merchant site. When the cardholder, URI, submits their payment information and places the purchase, the merchant can elect to initialize the 3D Secure protocol to request cardholder authentication. This authentication request from the merchant is routed to the issuer, and then the issuer will then authenticate the cardholder using a variety of different methods, from risk-based authenticate assessments based on the purchase details and purchase environment, to one-time passwords, biometric authentication, or even requiring the cardholder to call the issuer, which is less than ideal. If the cardholder is successfully authenticated, the issuer communicates back to that merchant with a unique verification code for that purchase. The merchant can then proceed with the payment authorization using that code from that issuer as proof that the authentication has been performed. So let's start with a little bit of background on the 3DS protocol. The original 3DS protocol was introduced by Visa in 1999, and it's since become the de facto global standard for online authentication. It's used by the major card schemes and vendors. So while the 3DS protocol, the original one, has provided a solution for cardholder authentication in e-commerce transactions, it has faced its share of challenges and barriers to adoption in many markets. For one, the protocol was specifically designed for browser-based purchases, so buying on a website on your computer. But it wasn't designed with app-based or connected device purchases that we see in the market today. The experience was also kind of clunky, so a lot of times it required windows and screens from that issuer to pop up in the merchant checkout experience as a pop-up or an iframe, and oftentimes this confused or alarmed cardholders. It seemed like phishing. this led to a lot of increased shopping cart abandonment rates. So to address these challenges, in 2014, Visa and MasterCard developed and contributed a draft of the 3DS 2.0 specification to EMVCo for the benefit of the entire industry to develop together the next generation 3D Secure protocol. The 3D Secure 2.0 protocol was published in October 2016 by EMVCo. The new protocol sought specifically to improve the user experience, provide more data for authentication and security, and provide flexible device and channel support. So one of these improvements included support for new and future authentication methods, one of which is biometric authentication. So how does this relate to Visa and what we're doing here? We at Visa believe that biometric authentication enables issuers to create simpler and more secure cardholder authentication experiences in many use cases, including 3D Secure cardholder authentication. Today, we already see a growing number of our issuers offering biometric authentication as a method for mobile account login, so your banking app on your phone, reducing the friction associated with PINs and passwords. In addition to this, we see an opportunity for issuers to allow cardholders to authenticate online payment transactions with the same biometrics. For example, when the 3D Secure protocol triggers the issuer to authenticate the cardholder, instead of the issuer sending a one-time password to the cardholder's phone via SMS, they can instead trigger a push notification. The push notification can allow the cardholder to open their app, view the transaction details, and authenticate using their biometrics. I'll be showing an example of this in a bit. We see that cardholders are very open to this idea of payment authentication with their biometrics. In 2017, Visa conducted a study which showed that 73% of the global customers surveyed would be comfortable using their biometrics to authenticate a payment. And then finally, payment transactions and logins not the only use case. By integrating biometric authentication triggered by a push notification into that mobile app, the issuer's mobile app, issuers have the opportunity to also incorporate biometric authentication in a variety of other cardholder interactions. Some ideas are verifying account detail changes when you change your mailing address or change your contact phone number, to verifying that the cardholder is actually the user on the phone with the issuer's customer support team when they're calling in by sending a push notification to that phone. So in all three of these use cases can use the same biometrics. So far, I've talked about the high-level concepts of the 3D Secure protocol, its history, and what it aims to do. And I walked through some sample biometric authentication use cases that issuers can implement into their apps. We'll next move on to the solution that Visa is building to help issuers create these biometric authentication experiences. Last year in 2017, Visa introduced the Visa ID Intelligence solution, a suite of authentication services to connect Visa's clients to vetted authentication technologies. Through Visa ID Intelligence, Visa clients can integrate these technologies using Visa's APIs and SDKs to get access to all the service providers Visa has partnered with. One of these services is the Visa ID Intelligence Biometrics service, a solution that will allow issuers and other Visa's clients to use the FIDO authentication protocol with specifically using biometric authentication to help address all the sample use cases I listed in my previous section. So behind the scenes of the Visa ID Intelligence biometric service, Visa will deploy and host a multi-tenant FIDO server to manage user registrations, authentication requests, and the FIDO policies that Brett talked about for registration and authentication. So Visa manages the redundancy and failover for a highly available production service, giving access to this FIDO server. The FIDO server is compliant with FIDO UAF specifications. It is compatible with certified FIDO authenticators. It allows for the secure registration of FIDO authenticators to servers and supports both login and step-up use cases. The biometric service enables clients to create and manage multiple FIDO policies for enrollment and authentication. So our issuers can choose what types of authenticators they want to allow for different transactions, and perhaps what certification levels they want to specify. And finally, they can manage multiple applications across iOS and Android platforms. The biometric service also provides Android and iOS SDKs, helping Visa's clients support FIDO authentication in their mobile apps. These SDKs will help clients quickly integrate with authenticators on their users' mobile devices, so helping clients eliminate that need to code for specific devices, the long tail that Brett was talking about earlier. The SDKs help enforce a range of FIDO policies, providing developers with tools to automatically display to their users on that mobile app only the authenticators that are applicable for that specific transaction type. The SDK will take into account the device's capabilities, so what sensors, what hardware is available on the phone, what authenticators are on the phone, the user's enrolled authenticators, what the user has enabled in the past, and then the issuer's policies of allowed and disallowed authenticators. In addition, the SDK also bundles additional biometric authentication capabilities for face and voice, helping developers to integrate face and voice authenticators, additional ones, into the mobile app. Since the biometric service leverages the FIDO UAF protocol, the biometric service in each authentication event will help verify the biometric, the user device, and the mobile app that the user is running during each authentication event. So let's move on to how the Visa Biometric Service can be used for cardholder authentication during a 3D Secure 2.0 transaction. So let's start with what I, a cardholder, might see if I'm enrolled in a program with my issuer. So in this example, my issuer will be Digital Bank, to use my biometric, my face, to authenticate a payment transaction. Here we show an example where I am making a purchase on the electronic store mobile app. I'm buying a smartwatch and a smartphone. Here we show an example from the mobile app, but you can also imagine that I could be on a computer browser, a mobile browser, or even buying from a connected device. When I click place order, the merchant, the electronic store, will trigger the 3D Secure 2.0 protocol, requesting that my card issuer perform cardholder authentication on me, making sure that I am eligible to use this card to make payments. In this case, when my issuer, Digital Bank, receives the authentication request, Digital Bank decides to send me an out-of-band step-up authentication challenge. I see a push notification from the Digital Bank app on my mobile device. I'll click on the push notification and open the app. Here, I'll see the purchase details and can approve the purchase from the mobile app, authenticating with my face. When the authentication is complete, I'll go back to the merchant app, and the merchant app will show a success message, and I will be able to proceed to the next step. Since the authentication was successful, the merchant sends the payment to payment authorization, and the transaction is complete. Next, we'll talk about what's happening behind the scenes here. To begin, we actually need to start with an understanding of the 3D Secure 2.0 environment and get an understanding of the high-level interactions between the different players. So on the top left here, we have the 3DS client, which can be at the merchant's website, the merchant's mobile app, or a connected device. So in our previous example, it was the electronic store mobile app. The cardholder will interact with the 3DS client. So I am on the mobile app. When the cardholder, I hit the place order button, the merchant will process the order. In the 3DS world, the merchant or the merchant's acquirer is represented by the 3DS requester in the top right corner. In our previous example, the 3DS requester was the electronic store. The 3DS requester maintains what is called a 3DS server to make authentication requests and receive responses. The 3DS server is responsible for sending the authentication request to a directory server maintained by a 3DS program such as Verified by Visa. The directory server shown in the middle can be thought of as a lookup table which will route that authentication request to the issuer. The issuer, in my example, which was Digital Bank, maintains what is called an access control server, also known as an ACS, to process the authentication request. The ACS here is shown on the bottom left. If the issuer, via the ACS, determines that the cardholder needs to explicitly authenticate with a 3DS authentication challenge, the ACS will send a response back to the 3DS server via the directory server, indicating that a challenge is needed. So here, the Digital Bank app is determining that I need to authenticate this with my biometric. The 3DS server that will then initiate the challenge, sending it back to the ACS via the 3DS client on the left. And this is where biometric authentication with the Visa ID Intelligence biometric service can come in. When the challenge request comes to the ACS provides the necessary information about that transaction to the issuer. So the issuer from the issuer servers can trigger an out-of-band step-up authentication, requesting the consumer to authenticate using their biometrics. To trigger the out-of-band authentication request, if the issuer has integrated the Visa ID Intelligence biometric service, in step 1, the issuer server will first initiate a new FIDO authentication request using the Visa ID Intelligence biometrics API. In step 2, the issuer will send a push notification to the mobile app on the user's device, containing the details about that authentication request. And then finally, in step 3, that push notification will trigger a series of events. It will trigger the app to retrieve and display the information about that transaction to be authenticated. It will retrieve the information about the FIDO authentication policies for this particular type of authentication. This policy is defined by the issuer, and retrieve the FIDO authentication challenge. The issuer's mobile app, which has implemented the Biometrics SDK, will then prompt the user to verify their biometrics. So ask me to show my face. It will, upon successful verification, it will unlock the private key for the FIDO authenticator, sign the authentication challenge, and return that signed challenge to the FIDO server hosted here at Visa. Visa is shown on the left here. Note that this may require more than one interaction between the app, the issuer server, and Visa ID Intelligence, but for simplicity's sake, we've just represented all the flows in one step. Next, the biometric service and the FIDO server will verify the signed challenge and return the final authentication results to the issuer server. And the issuer server will communicate that results back to the ACS. In the end, the ACS will resume and complete the 3DS authentication protocol, sending that result back to the 3DS server via the directory server. If the authentication is successful, the 3DS requester, remember this is the merchant, the electronic store in my example, can choose to proceed with payment authorization. The authorization is actually not shown on this slide. If the authentication was not successful, I didn't open my app, my face didn't match, I gave up on the purchase, the merchant can deny the purchase. So that comes to the end of that use case I've described here. I know I've covered a lot of different topics here at a high level, from the 3D Secure protocol to biometric authentication use cases, to Visa ID intelligence. I hope it's provided a good starting point for understanding how FIDO authentication and biometric authentication can fit into the card payments environment. So for more information on some of these topics, please visit the links listed here. Visa will also be at Money 2020 this year in Vegas, so look for the Visa kiosk in the pavilion at the FIDO Alliance booth. Thank you.
Great, thanks, Tanha. So this is Andrew again. I'm going to run us through some Q&A. We've had some questions asked in the dialog box. We've been answering those as we can. Let me start off with a question here for the Visa team. So let me note also that there's some added panelists in addition to Tanha from the Visa team who may chime in on some of these answers. So let's look at this one here. What biometric modalities are supported by Visa's biometric solution, and what operating systems will this be available for? So Tanha, maybe you want to take that.
Yeah, so the modalities that are offered through the Visa biometric solution is fingerprint on the iPhone and Android, iOS and Android devices that offer fingerprint sensors. We also can add additional face and voice authenticators, and those require a minimum operating system for iOS and Android, and the face authenticator requires a front-facing camera, while the voice authenticator requires a microphone.
Okay, very good. Brett, you answered this one midstream, but I think it's worth raising for added context. There's a question here. Let's assume one of the FIDO certified devices is compromised. Can FIDO revoke its metadata certificate to inform all relying parties that the authentication using that device should not be trusted?
Yeah, so the metadata entries would be modified in that case. It's part of our security program. It's in the governance documentation. It's part of our expectation. You know, implementations do get compromised from time to time. And so we're anticipating that we will discover some flaws, and maybe an entire class of authenticator or model will have a known exploit. And we do plan to have a way of updating that device's metadata so that you will know that the next time the device tries to connect, it'll be in the metadata that you've subscribed to. So it isn't a certificate per se that gets revoked. Again, this is not PKI. I guess there's PKI for the metadata service, in that the OEM does cryptographically verify that yes, these attributes are coming from me. But what would be updated is that particular value in the metadata around whether it's a known exploit for that authenticator or not.
Okay. Thank you. Here's another question. And Tanha, maybe you start. Brett, maybe you have added perspective here. What's the expected demand for biometric step up in 3DS? So where's the market demand for what we're looking at and for the value add FIDO can bring to the 3DS workflow?
Yeah, so as I mentioned earlier, we expect that more and more issuers will add the ability to perform step-up authentication with biometrics, because today they already use biometrics for app login, and consumers are used to it. They're used to using their fingerprint to log into a lot of things on their phone. And then with addition of PSD2, strong consumer authentication requirements in Europe, we expect that cardholders will find that biometric authentication and that single gesture authentication will be a low friction solution for authentication. And standards like the FIDO UAF authentication standard will help provide the security requirements needed to meet those regulations.
Okay. Brett, do you have any other thoughts on that?
Yeah, I think the goal of 3DS, especially the 2.0 series in 3DS, is to address one of the earlier 3DS challenges with 3DS system before version 2, which was the step up the user experience, right? So I think that a lot of the attention has gone into improving the user experience, allowing the issuer to assess the risk of that transaction silently behind the scenes, and to try to get those step-up challenges as close to zero as possible. So while basically FIDO's helping in two ways. If you do have to do a step up, you can do a FIDO step up, which is going to be a better user experience and more reliable for you. And then what we're doing with the standards integration between FIDO and 3DS is allowing 3DS to pass the very useful authenticator data to the issuer so that they won't need to step up. Like, oh, okay, well, I now have really strong proof of the characteristics of this authentication event, so I don't need to do a step up.
Okay. Brett, another question for you. Can FIDO handle device sharing? Can FIDO handle the device sharing use case? The key pair is per device or per user?
Authentication keys are per account. So that would be, even if I have 3 accounts at one service, I have 3 different key pairs. So really isolating the credentials so that those credentials don't become correlation handles that can be used to track users. Very privacy by design architecture. In terms of shared device, so it comes down to the device's ability to, is it a multi-user device? If it's a multi-user device, if the device OS itself is multi-user aware, then you can have isolation of those credentials. If the application itself decides to be multi-user aware, then you can get separation of account credentials. But if you think about the kind of popular smartphones on the market today, they tend to not be a multi-user. Like if you have a family sharing, you share your phone with your kid, then that's going to be out of scope in terms of what FIDO can offer you in terms of separating, was this the child or was this the parent? That really comes down to the user verification binding. You're trusting that the user verification is bound tightly, and the device APIs themselves. So we do have a feature, it's an extension feature in the FIDO standards to be able to tie a authentication private key to a particular biometric template on the device. So that's an optional feature. Not everyone implements that, but you can take advantage of that if you feel you need to know, was this the fingerprint that was used when my customer first enrolled, or is it one that was added later? And again, your mileage may vary because your user has no idea what the fingerprint was that they first enrolled, so you might be creating more friction than you want to if you really want to discriminate on that. But it is a capability that can be made aware to you. Okay,
great. So Tom, I'll come to a question of clarification, I guess, for Visa. What's the difference between 3D Secure and the Visa Biometric service and Verified by Visa?
Got it. So that's actually a really common question. So 3D Secure is the industry-wide messaging protocol for online authentication. So that's the 2.0 version is developed by EMV Co. And that's the protocol that I've introduced and described in my presentation. Verified by Visa is a 3D Secure program, and it's Visa's online authentication service built based on the 3D Secure protocol. And finally, the Visa Biometric service is separate from all that, and it provides the FIDO server and SDK to help issuers and Visa's clients implement FIDO authentication.
Okay, thanks for clarifying. Brett, here's a good question. What happens if the device has vulnerabilities and the biometric authentication itself is compromised? So for example, when iPhone X was launched, someone spoofed it with a picture. How is FIDO helping address this?
So that, I'm going to introduce a term, so Presentation Attack Detection, or PAD. This is where the biometrics industry has gone since first introducing biometrics at scale in the consumer space. That is the trick, right? So initially the focus was on false accept rate and false reject rate, but now the focus from a security perspective, the focus is on spoof detection. So the first thing I'd point out, if you're looking at comparing these solutions to passwords, is, anybody can steal your password, but if you're trying to attack a biometric, if it's a FIDO biometric, you're going to have to steal the device to even attempt an attack. So that's kind of obvious. But that being said, we are working on improving spoof detection or presentation attack detection. And it is a requirement in our new biometric certification program, which surprisingly is the first of its kind. There actually wasn't an independent third-party biometric testing and certification program for the consumer market. I think that's an artifact of the biometrics industry kind of really having its roots in border control and law enforcement, where the buyers could do these assessments themselves. Here, when you're looking at a long tail of hundreds of maybe thousands of devices, there's no way a bank or a merchant is going to do due diligence on all of those things. So our members who are in that category said we need a certification program, so I can just get level 1, level 2, and I can make an informed decision, or I get a pass-fail. With biometrics, it's a pass-fail. So we are, not only are we introducing that and making presentation attack detection a requirement for your biometric certification, we plan to keep tightening that over time and partner with the biometrics industry to get better and better at spoof detection year over year as we revise and refine and elevate the requirements of our program.
Okay. So thanks so much. That brings us to the end of our time here today. There were more questions that we did not get to. We'll do our very best to respond to some of these. Anything that was very targeted at Visa, we'll send to that team for response. Anything for FIDO, we'll do our best to respond. Also, you can always reach out to FIDO Alliance by email at help@fidoalliance.org. Please do send us email there. Additionally, the webinar again is being recorded. The archive and slides will be emailed to you and posted on our website. So stay tuned for that email with that direct link. Again, please take a moment to fill out the survey at the conclusion of the webinar. If you want to follow us, the next slide shows obviously our website. We do have an active Twitter presence as well. You can ask us questions there and on LinkedIn. So with that, I'd like to thank our speakers today and thank all of you for attending this webinar. Stay tuned for a link to the archive, and we'll look forward to catching you on a future FIDO webinar. Thank you.